Okay, so this is hopefully some explanation into the homework from cross sections out of the book. So I will just do setups, and then hopefully that will just kind of at least get you past maybe where you're getting confused. So the questions were 1, 5, 42B. 1, 5, and 42B. Okay, so let's look. So question 1, there was a picture of an XY axis, and it says the solid lines between planes perpendicular to the x-axis at x equals -1 and 1. Okay, so kind of think here, so we've got and then the cross sections are perpendicular to the x-axis and they run from the semicircle -1 minus, so semicircle this way, which that's the equation -1 minus x squared, and then semicircle this way, so that would be positive 1 minus x squared. Okay, so now in addition it says the cross sections are circular discs. Okay, so essentially, like, basically this becomes a sphere if you think about it, because if this is my circle and then this is the diameter, and if you imagine them coming up and over, okay, and then around, basically we have a sphere. So it says that we're trying to find a formula for the cross section of the solid. Okay, so right now I'm trying to find a formula for one of these circles. Okay, so it's hard to kind of imagine, but these circles are coming up and around this way. All right, so I hope we would agree that the area of a circle is pi r squared, so really we got to have a formula for r. And r is half of the diameter. So lucky for us, we can use either one of these equations. So r is the square root of 1 minus x squared. So the area of one of these circles is pi times, and in place of that radius, I am going to put square root of 1 minus x squared, but its radius squared, so squared. Therefore, what happens when we square a square root is that goes away, and so this is your equation. You were only asked for the area of one of those, okay? So you're not asked to do the whole problem. Next question. And they drew a little picture here so you can see it, okay? What if instead they were squares? And so you can see the base of the square goes the length. All right, so the base of the square goes from the top of the semicircle to the bottom of the semicircle. I think we would all agree that the area of a square is just the base or the side squared. So now we have to figure out, well, I need to know an equation for this entire length, because that's going to be the base of my square, and then I need to square it. Okay, so we can go ahead and use our idea of subtracting, or if you want to think about, hey, these are equal pieces, so I can double this, but the distance from the top curve to the bottom curve is 1 minus x squared minus -1 minus x squared. So hopefully you can see I have 2 of those. Okay, so that is my base. Now the area means I have to square it. And so area equals this squared. Okay, so set up for that. C. Cross, I hope you get the idea with this. D, they're equilateral triangles, and so we can, this is B. B, the diagonal is in there. So it says the length of a square's diagonal is root 2 times the length of its sides. So basically what I would have to do is divide it by root 2 and square it. Let's look at D. I'm not super concerned about C. Equilateral triangles, remember how we talked about? Here's an equilateral triangle, side length S. We wrote down that this is root 3 over 2S. And so 1/2. Okay, so we got the root of 3. So squared, and I can cancel that to get root 3 times 1 minus x squared. If you want, you can put them together in a parentheses over 2. Because these are both underneath, you could put the 3 in with that expression. Okay, hopefully that was helpful.